All right, example 3. X to the negative 3 squared, y, x, y to the negative second, negative third, over y to the squared to the third, y to the negative third, x squared cubed. So, what I say in this process, this efficient technique is this guy, and this guy, and this guy, and this guy. That's your main priority. Parentheses in these problems cause errors. They cause mistakes all day and twice on Sunday. All right, twice on Sunday.
So don't do our homework on Sunday.
Do your homework on Sunday. Just be more careful. All right.
Or do it on Saturday.
Or do it Friday. Then you have Sunday out. There you go. All right. Good job, Kaylin. Kaylin's plan. Do your homework on Friday when you have homework over the weekend. That way you have Sunday out. All right. Anyway. All the stuff I don't have highlighted, this x and this y to the negative third, are all behaving themselves. So leave them alone. All right. So I'm going to do all these evaluations in red, or these simplifications in red, and all the stuff I leave alone I'm going to keep blue. Okay. So watch what happens here. X stays x, but I'm going to make it the first power. Again, it's very important. Everything has a power attached to it, so you know that it has purpose. All right. X to the negative 3 squared, the rule tells me that when I see this structure, inside times outside power, multiplication rules are in effect. Negative times positive makes a negative. 3 times 2 is 6. This y is still there to the first power. Now notice we have x and y in here. This x is to the first power, so we're going to get an x and a y out. 1 times negative 3 makes negative 3. Negative 2 times negative 3 is positive 6. Okay. That y to the positive 6 illustrates why we deal with negative powers in the second step. Because when we multiply, negatives could become positives. If you deal with the negative powers first, then you multiply, all of a sudden maybe you have negative powers again, you've got to deal with them again. So that's why we deal with that in this first step. All right, down here, this y, 2 times 3 is 6. This y behaving itself for right now is to the negative third power. It stays as is. This x in parentheses, 2 times 3 is 6. That's all step 1 is or ever will be. Things that aren't in parentheses stay what they were. Things that aren't in parentheses are evaluated. The parentheses disappear. Don't continue to keep parentheses in your problem after this step. Make them go away. Once you apply the rule, the parentheses are gone. Step 2. Anything with a negative power or a 0 power has to be dealt with. So, I've got a negative power here, here, and here. Everything else is a positive power, right? So everything staying where it belongs is going to be written in black. X to the first, y to the first, y to the sixth are in black on top. Y to the sixth, x to the sixth on the bottom. It doesn't matter what order you put them in. Me personally, I go ahead and move everything that's not negative power first. Make sure I dealt with it. Then I move my negative power stuff. This y cubed on the bottom to the negative third belongs on top. This x to the negative 6 on top belongs on the bottom. This x to the negative third on the top belongs on the bottom. This happens a lot. Notice there's an x to the 6 that was behaving itself. There's another x to the 6 moving down. And if you don't be careful, you might write one down, think you've already dealt with both of them, and then you move on. So be careful with these. That's the most common mistake on these problems. Once you understand the process and get good at it, is you just leave something off. So be careful that everything is still there. Step 2 done. Step 3. On top, I've got too many y's. On the bottom, I have too many x's. All right, so step 3 is to deal with that situation. So the x to the first on top and the y to the 6 on the bottom are both behaving themselves. I like my x's and y's to line up over here, so I'm going to put x here, y there, just to leave a y space there and an x space there. Not a requirement, but that's just what I do. Y, y, y. 1 plus 6 plus 3 is 10. Yeah, that's right. Why did I take Algebra 2? Should have taken something else. All right. But notice there's 3 letters there. Add them all up. 1 plus 6 plus 3 is 10. X, X, X. 6 plus 6 plus 3 is 15. Oh my gosh. All right. That's all step 3 is or ever will be. You're just adding up a bunch of numbers of the same letters on the top and the bottom individually. Step 4. Too many x's. X belongs in the bottom to the 14th power because 15 minus 1 is 14. 15 is bigger, that's why it's in the bottom. Too many y's. Y belongs on top because 10 is bigger. 10 minus 6 is 4. That's the power. There's your answer. The problems will be of this variety right off the bat. They might even throw some numbers in there. Let's just say for some reason, let's put negative 2 to the negative third power. Let's say that was in the original problem. So that is not the same as this. All right? So it would still be, I put it in the front here, -2 to the -3rd power. But this would be dealt with here. It belongs on the bottom. And notice I'm keeping the parentheses around it because the parentheses mean the minus sign and the 2 are being raised to the power. All right. In this step here, that's when I would deal with the power. -2 to the 3rd power is -8. It's on the bottom, so it stays -8 on the bottom. Some people want to move that -8 to the top because it's negative. It's -8 to the 1st power. It's a positive power. It's right where it belongs. It's just a negative number. Okay, so if a number does show up in your work, deal with the evaluation number in the multiplication step. Step 3, deal with the negative power in the power step. Don't deal with it here ever. All right? If it's in parentheses, whatever, go ahead and leave it around for one more step. Negative powers move, evaluation happens, and then the number is whatever it is. If there's some other number here, let's say there's a 4 here, 4 rate reduces to half. Reduce it. Using numerical reduction of fractions because they're just numbers. They act like numbers. These are letters, they act like letters. They're different. So keep that in mind. If numbers do show up, you deal with them as numbers. Negative powers in the negative power step, evaluation in the multiplication step, and then you're probably done. There might be a reduction in the fraction step.